So now, welcome to this video once more again. Now here we're going to apply the basics that we have just learned in the previous video. So now, here we have the expressions provided to us. We need to solve them. I'm going to start with these two first questions and make sure that you understand how to solve these questions. Now, let's have a look at example number 1. And the statement here, we need to simplify. So simplifying, that means we need to break it down into smaller pieces. So now I'm going to rewrite question number 1 as it is. So now, question number 1, it says to us we have negative 3x to the power of negative 5 multiply by y to the power of 0. It's not 6, it's 0. Might be confusing. Multiply by 16 x to the power of 2, and then divide by 12 to the power of, by 12x to the power of negative 4. In this case, we need to simplify this expression over here. So remember, we spoke about the golden tips on how to simplify the expressions. And we also did some of the laws of exponents, and we also spoke about the definitions of laws of exponents. So we're going to apply all of those basics that we have discussed on the previous video. Now, in this case, what are we going to do? What we're going to do is, it's very simple. What we're going to do is, we can start with the numbers if you want to, by writing them in a prime number, numeric. We can see that we have the basis there, which is negative 3, we have 16, we have 12, and we know that we can write this in numeric, because we have the numeric basis, we can write them in a prime numbers. But I don't like doing that on questions like this. On questions like this, you can just deal with your numbers aside, okay? And then let's focus on the exponents of these variables, which is, let's focus on the basis of these variables, x, y, okay? We can focus that using laws of exponents. We're gonna collect the exponents by applying laws of exponents, okay? So this is what I'm going to do. I'm going to start with the numbers, okay? I'm gonna say negative 3 multiply by 16. You can do that, right? You can say negative 3 multiply by 16. If you want to play with the bases, it's still fine. But for now, I don't want to do that. I'll do that on specific questions whereby the expression is actually presented with bases with numbers only. So you're going to say negative 3 multiplied by 16 is going to give you negative 48. And then you're going to say negative 48 divided by 12. You're going to get negative 4. So that means so far we have negative 4. Now we are done with the numbers. Now let's deal with the basis, the variable basis. In this case, we're going to start with x, right? Applying the laws of exponents. Now we are collecting the exponents, applying laws of exponents. Now at the top, we are multiplying. Can we see that? But we have x to the power of negative 5, and then there we have x to the power of 2. Because now we are multiplying at the top, we're going to have to add their exponents because we are multiplying the same basis. So that means adding our exponents, and the first exponent is going to be negative 5. The second exponent we are adding, remember, is going to be positive 2. Do we have any other base of x? Yes, we have another base of x, which is at the bottom. In this case, because it's at the bottom and we are dividing. So remember, at the top, we are multiplying the same bases, but at the bottom, we are dividing the very same base, which is x. So that means when this x goes at the top, it's going to be negative, or we can just minus. So because this one is at the bottom, we're going to minus its exponent. So we're going to minus negative 4. Then we are done. We no longer have x's. Now we have only one y, which is y to the power of 0. Do we have any other base that has a y? No, we have only this one over there. So we'll just write it as it is. Now, continuing with the very same expression to solve it. Now let us add the exponents, subtract the exponents of the case, whatever the case may be. So here we have negative 4x. Therefore, what is negative 5 plus 2? We're most definitely going to get negative 3, right? And then we're going to multiply this. It's going to be positive 4. And therefore, remember the definition of laws of exponents. We know that y to the power of 0, anything to the power of 0, will probably most definitely give us 1. And therefore, now continuing with our final answer, 1 multiplied by that is going to be that. So now we're going to have negative 4x to the power of what is negative 3 plus 4. It's going to be 1. Therefore, that means this will be our final answer from this expression over there when we wanted to simplify it. Now we move to question number 2. I'm going to rewrite it once more again. Now question number 2, we have root of a multiplied by fourth root of b to the power of 3 multiplied by, in bracket, ab to the power of 1 over 4, then divided by a to the power of 3, 1 over 4. Again, we have the expression that we need to simplify. Let's use all of the basics that we have learned so far. Remember, from the golden tips that I gave to you or that I showed you, we said that when your bases are written in a form of sets or roots, we need to change these roots into the exponents because we need to simplify this expression over here. So the first thing that we're going to do is we can see that we have root of a. We need to change this root into exponential form. So now, applying all of our basics, we know that this is square root, right? Square root of a. So square root of a, changing this to exponential form, is going to be 1 over 2, right? And therefore, we're going to say this multiplied by, remember, now we have b to the power of 3, right? Which is this 1 over there. But now we have fourth root. So let's change this root into exponential form. So it's going to be, because it's fourth root, it's not a square root, it's not a cube root, it's a fourth root. So that means changing this to exponential form, it's going to be 1 over 4 multiply by, and then there we have ab to the power of 1 over 4. Let me just write it as it is because I'll do it with this one. So there I'm going to have ab to the power of 1 over 4 divide by, now we're going to apply law number 3. Remember, law number 3 is raised to power. We're going to multiply our exponent within the bracket. So that means here we're going to have a to the power of, what is 3 multiplied by 1 over 4? It's going to be to the power of 3 over 4. Now, as I continue with my expression, while I'm simplifying it, I'm going to rewrite this as it is, which is a to the power of 1 over 2 multiplied by, now we're going to have to distribute our exponent inside of the bracket, which is law number 3, raised to power. So we're going to say 3 multiplied by 1 over 4. It's going to be b 3 over 4 multiply by, again, we're still going to have to distribute this exponent inside of this bracket. But remember, we're going to multiply each base by this exponent, which is 1 over 4. We're going to multiply their exponents by 1 over 4. So for a, we're going to have a to the power of 1 over 4 multiply by, for b, we're going to have 1 multiplied by 1 over 4. It's going to be 1 over 4. Therefore, we write our long division line, and therefore at the bottom, we still have a to the power of what? 3 over 4. Now, continuing with our expression, what's another tip that we're going to have to use in this case? We're going to have to collect, right? Using laws of exponents, we're going to collect the exponents. Using laws of exponents, we need to consider the same basis. So now we have the basis of a. And look at the top. At the top, we are multiplying the a's, right? So that means I'm going to start by writing a over there. And therefore, first exponent of a is 1 over 2. The second exponent of a, because I'm multiplying at the top, I need to add my exponent. So I'm going to say this exponent, which is 1 over 2, plus that exponent, which is 1 over 4. Do I have another a? Yes, at the bottom, below the division line. So meaning that means I am dividing the same variables and the same basis. I'm dividing the a's. So that means I'm going to have to subtract this exponent. So I'm going to say here I have negative 3 over 4, right? Now I'm done. with the a's. Now I'm going to talk about the b's. I'm going to write my bases, which are b's. Let's move to b's. The bottom, we are just the top, we just multiplying. So that means I have b and b, and therefore the exponent for this b is going to be 3 over 4. And because I'm multiplying, I'm going to have to add my exponents, and that one is going to be 1 over 4. Now let's continue to further simplify this expression. So you can quickly punch this in a calculator, but let me do it with you. I'm going to start with this one. I know why. So 1 over 4 minus 3 over 4. I see that the numerator are the same. That's why I didn't want to start with this one. The numerators are the same. So that means it's going to be 1 minus 3 is going to be negative 2 over 4. And negative 2 over 4 is going to be negative 1 over 2. Negative 1 over 2, subtract this negative 1 over 2, you're going to have a to the power of 0 over there. Multiply by b to the power of 3 over 4 plus 1 over 4. The numerators are the same. Sorry, the denominators are the same. So we're going to add the numerators. So we're going to have 4 over 4. So that means we're going to have 1 over there. Definition of loss of exponents, we know that a to the power of 0 corresponds with 1. So that means our final answer will just be b, because 1 multiplied by b, which is b to the power of 1, it will be b. Therefore, this will be our final answer.